Hi, in this video we're going to look at condensation reactions. What are they? How do carboxylic acids and acid chlorides react with other molecules to make both ester and amide functional groups? If you find this video helpful, don't forget to share, like and subscribe, and look out for new videos. Okay, let's look at some condensation reactions to do with carbonyl groups. So, carbonyl groups, condensation reactions involve two molecules coming together to produce one larger molecule, and in the same process they also produce a very small inorganic molecule, either usually hydrochloric acid or water. So we can take a primary alcohol and a carboxylic acid, and if we put them together we make this new type of compound called an ester. We can also use an acyl chloride and an alcohol to produce an ester, but we can also take an acyl chloride and, as we looked in the previous video, add an amine to it and produce a secondary amide. Secondary amide. Or we can take an amine and add an acyl chloride. Actually, this is the same way, but it's just a different way around, and we can get a secondary amide. So we'll look at these in a bit more detail. So carboxylic acids and alcohols. This is called an esterification reaction, but it also is a type of condensation reaction. So we would carry this out under reflux because this reaction actually takes a wee while. It's at equilibrium. So notice the equilibrium arrow. So what happens here is basically if we take the carboxylic acid and the alcohol, we are removing a water molecule, because the concentrated sulfuric acid will come along and take a whole water molecule. It has an affinity for water. Okay, it's really going to rip water off places, so it's going to take it away from here, and then it joins back together where the OH and the H was taken away. This is a condensation reaction because we are taking two smaller molecules to make a larger one, and we're producing a small inorganic molecule as well, this H2O. This bond here, this group in the middle here that has joined them together is called an ester bond. So, what if I wanted to produce an ester in the lab? Well, esters are volatile. The alcohols that we produce esters from are volatile. We need to heat them to make the reaction happen. So we're going to have to heat up the mixture, but we want to stop any of the volatile liquids or the liquids that would easily boil and evaporate. We want to condense them back and make them fall back into the mixture to keep reacting, or not to lose them. So we take a round bottom flask and we add a Liebig condenser. We put the reactants in the flask, the acid and the alcohol. We're going to add some concentrated sulfuric acid. Remember, that's going to be the catalyst for the reaction. It removes the water. And if we remove the water, if you remember the previous slide, we are taking away a product that drives the reaction, the equilibrium to the right, favors the forward reaction, and we're going to produce more products. So that's why we add the sulfuric acid. We put some boiling chips here, some small bits of quartz in here to stop the bubbling from being too large, the bubbles, and it doesn't over bubble. We just get small drop bubbles coming off. We attach the Liebig condenser, of course, to collect anything that we might, volatile gases that might be coming off, making them drip back into the mixture, and we heat it for 10 minutes. So once we've done that, hopefully the alcohols and the carboxylic acids have mostly turned to the ester, but not all of it. There'll still be some acid left, and there still might be some alcohol left. So we let it cool, and then we're going to pour this reaction mixture after it's reacted to this separating funnel. Now, what will happen is when you put it in the separating funnel, you are going to add to this some sodium bicarbonate solution, which is an aqueous solution, and you're going to stopper it and give it a wee shake. Now you're going to take this top off, and you're going to get a wee bit of fizz coming off, or a wee bit of air, because the sodium bicarbonate would have reacted with the acid to neutralize any carboxylic acid or sulfuric acid that's left. So what's happened is we've neutralized that by using the sodium bicarbonate. We shook the solution to make sure any of the non-reacted alcohol was dissolved in the aqueous layer. And now what we're going to do is we're going to turn the tap so that the non-aqueous layer will run out the bottom. And we keep the less dense organic layer that will include all of the ester at the top, and that's how we separate the esters from the alcohols and the carboxylic acid. So we actually we do the sodium bicarbonate and mixing a couple of times. Once we're happy with that and we've drained off all the aqueous layer, so we stop the tap as soon as the organic layer gets down to the bottom, we add some anhydrous sodium sulfate. That will get rid of any water that's been dissolved in the organic layer or is mixed in the organic layer, and we will get a pure substance. And that's how we make an ester in the lab. We can also carry out esterification with acyl chlorides. So just like we did with the carboxylic acids, we can add an acyl chloride to an alcohol. However, notice this is not an equilibrium reaction. Acyl chlorides are very reactive. When I add them to the alcohol, they will react vigorously. We will lose the hydrochloric acid, the small molecule, and we will combine these two molecules to make a larger organic molecule. So acyl chloride plus alcohol will produce an ester with this ester group in the middle. Okay, so the last type of reaction with an acyl chloride is we can take an acyl chloride and we can react it with an amine. So the acyl chloride is it's a very reactive functional group. If we add an amine to it, the hydrochloric acid will be removed and it will join the two molecules together at that point, making this amide bond here. Now, because remember the nitrogen is attached to two carbons, this is a secondary amide. This type of bond, called an amide bond, is also called a peptide bond. So biologists call this a peptide bond, and remember, peptide bonds are what hold amino acids together in proteins. Okay, so we've looked at the different types of condensation reactions. If we start with the carboxylic acid and we add an alcohol, we can see here that we can produce an ester. This is the ester we've produced. This ester could also be produced by an acyl chloride and an alcohol. The acyl chloride would have the same structure as the carboxylic acid, but of course it would have a Cl instead of the OH. And we would expect it to react without a catalyst because acyl chlorides are very reactive. Acyl chlorides will also react with amines. So it's going to carry out this reaction here to produce the secondary amide. And of course, an amide and an acyl chloride from here can also produce this secondary amide. Hopefully this has been a useful video going over the condensation reactions of carbonyl compounds. Look out for the next video where we will be looking at polymers, condensation polymers. Okay, if you've got to this part of the video, you've obviously watched all the examples that I had on those 3 questions. Hopefully this has fortified your understanding of geometric isomers and you are now well prepared to go and attack that exam. Good luck, and if you found this video useful, don't forget to like it, subscribe, and look out for new videos that I might put up by clicking that bell. See you later.